Home Assistant is a very popular home automation platform for automating your house using smart home devices. It's open source and the list of features that supports it just gets better and better over time thanks to the developers and the community that supports it. Now, one of the things that really appeals to me about Home Assistant is you can actually run it as a virtual machine. Now, what that means, for example, is let's say a new patch comes out. If I had this installed on a Raspberry Pi and I applied that patch and it stopped working, well, I'm going to have to find a way to reinstall that system back to the state in which it was before. That could involve actually having to reinstall the software from scratch and then recovering the backup. But with a virtual machine, what I can actually do is, well, I just take a snapshot of the actual virtual machine before I apply the patch. If something does go wrong, I just restore back to that snapshot and everything is back to where it was before. Everything is working exactly as it did before the patch was applied. So it's much, much simpler to do. Another appeal of virtual machines is that I'm no longer dependent on the actual underlying physical computer itself. So let's say I actually purchase Home Assistant on an actual computer that's been shipped to me and that's got the actual software installed. The problem I've got is if that computer were to break, well, that's it. My home automated solution suddenly stops working. And now I'm going to have to wait until an actual new computer gets shipped out to me. I could keep a spare to hand, and you could do that quite easily with Raspberry Pis. But one of the real appealing things about a virtual machine is that, well, if you've got a hypervisor cluster, all you've got to do is just instruct the actual system to spin that up on a different hypervisor node. And you can actually even set it up for actual redundancy, so it's all automated if you want. So if you're interested in learning how to install Home Assistant on a hypervisor like XCP-ng, for example, then stick around and watch this video, because that's exactly what we'll be going over. Now, the first thing that we actually need to do is to actually download the software, or more specifically, the actual Home Assistant image. So here we are on the actual website, and I must admit, nothing jumps out here actually saying where I actually download this image from, or any software for that matter. Most websites that I go to will always say something like, this is the download page and this is the support page, for example. So usually I would go there. In the case of Home Assistant, and I will include a link in the description for the website, but what we have to do is to actually go to this documentation drop-down menu and then click on installation. And then if we scroll through here, it gives you all the different operating systems and hardware that you can actually run Home Assistant on. Now, what we're going to be doing is to install Home Assistant, or more specifically the image, onto an XCP-ng hypervisor. And for that, we want to be coming to this option here, which is for Linux. So we'll click on this, and what it gives us is 3 different images, interestingly. One's for VirtualBox, so that's the VirtualBox hypervisor, one's for KVM, and one's for VMware Workstation. So although there's no reference to XCP-ng, Citrix Hypervisor, or Zen Server, it doesn't really matter because XCP-ng actually supports these VMDK files that VMware uses. So what we need to do is to actually click on this link, and what that'll do is download a zip file. We then extract that zip file out and it'll give us our VMDK file. And then we've just got to make that available to the actual hypervisor to use. What we're not going to be doing is going through some sort of import wizard where it actually builds a virtual machine for us. This is an actual VMDK file. It's the actual virtual hard drive, if you will, with the built-in operating system. So what we actually do need to do is to create a virtual machine. There's the minimum specs they give you to do that with. And then what we'll do is we'll actually delete the hard drive for that virtual machine, and we'll actually replace it with this VMDK file. So once you've actually downloaded this VMDK file, you've actually got to put the actual file where the actual hypervisor is going to be using it for that virtual machine. So that's just something to bear in mind, is that with XCP-ng, it's not like ESXi, for example, where I can just click on the actual data storage, for example, and tell it to upload a file from my computer. I've actually got to upload the file to the actual storage space myself. Now, in my case, I'm actually using NFS shares because I actually want to be running virtual machines like this on shared storage. So I've got an actual NFS share, which is used for shared storage, that all the actual hypervisor nodes have got access to it. So all of the virtual machines run on that. So in my case, I've just got to upload that actual file to the actual NFS share itself, where this virtual machine is going to reside. So that's the next step really, is to, once you've downloaded this actual file and unpacked it, is to actually build the virtual machine itself based on these specs. Bear in mind, you don't actually build your virtual machine with a 32 gig hard drive. It doesn't matter what spec you give that, you're going to delete it anyway and then replace it with that VMDK file there. Just bear in mind, this is the amount of disk storage space we do need to be able to accommodate it. One thing to bear in mind is you can actually start with these specifications here, but you can always just increase it on the fly. Basically, that's the really good thing about a virtual machine. It's not like an actual physical computer where if you run out of processing power, well, you're either going to have to upgrade the processor, possibly the motherboard as well. With the actual virtual machine, typically the hypervisor's got lots and lots of memory, lots and lots of processors, so you can just increase the capacity of the virtual machine typically on the fly. So it is a lot easier. So yeah, by all means, start with these minimum specs. If you want, add more as you want to, as you go along, as you get more and more smart devices basically added into the network. It's going to need more compute power, more memory to be able to accommodate that. But there's no reason why you can't just start with these minimum specs to begin with. But anyway, first thing we need to do is download that actual file, and then once we've done that, is to create our virtual machine. So once you've actually downloaded that VMDK file, the next step is to actually create your virtual machine. So this is basically like the framework, if you will. The operating system and the actual software is all contained within that VMDK file. It's a virtual hard drive. We just need an actual virtual machine to go with it. So I'm on Zen Orchestra. This is the community edition. So with this one, I've got access to pretty much every feature in here except something like Exosan, for example. It's not something I need particularly because what I've got is a pool of 2 hosts, for example, and each of these hosts has got access to shared storage through a NAS share using NFS. So they've both got access to the same shared storage, meaning any of these hosts that I'm going to put into this pool will have access to those virtual machines that I create. So yeah, something like hyper-converged storage where we replicate local storage between hosts, yeah, sounds great, would be useful, but it's not really something I particularly need, especially for like a home or a test lab. So if you're not already familiar with Zen Orchestra or even XCP-ng for that matter, I mean, I've actually created some videos that cover how to install XCP-ng, how to get this free Zen Orchestra Community Edition installed, how to actually attach XCP-ng to NFS, and even how to actually create an NFS share in TrueNAS if you're interested. So, I mean, by all means, if you want to find that out, go and check out the videos and, come back here and follow on from there. But the principle is pretty much the same no matter what hypervisor you're going to use. You're going to basically create a virtual machine, and then you're effectively just going to put a hard drive in there for that virtual machine to use. So that's the first thing we need to do then, is to create that virtual machine. There's different ways to do it with XCP-ng. One is just to go down to here, which is new, and then click on VM. Now, in my case, I've got to pick out a pool because that's the way this is. This is an enterprise hypervisor system. The idea is you've got all these nodes running in a pool. Any one of these hypervisors could be running an actual VM, and when it's properly set up, the idea is you just create a VM and the system will work out what's the best machine to work it on. It's got various rules about anti-affinity. These types of servers can't coexist on the same node. There's all sorts of clever stuff goes on, but for our case, we're just going to keep it simple. We've got a node with 2 hypervisors, and that's it. So we don't specify which hypervisor to run on, just the pool. So we select that. In our case, as I say, there's just the one. Next thing to do is to pick out a template. Now, this template basically details various information further down it, but we've got to specify what it is. You'll see there's certain things that are already in green, in other words, they're selected. Other things that are in that are coloured in black. It's a case of you need to fill that information in. Some of it will get done once you select the template, but it's a case of we've got to select a template at least to begin with. There's different ones on here, different types of Linux, different types of Windows, but for this particular installation, we're going to go with other, which is other install media. So it doesn't really put much in details in there. We're going to have to edit them anyway, but I'm going to call this one Home Assistant. Now, one thing to bear in mind is the name that we give this virtual machine has no bearing on the actual host name of the actual computer operating system. The two are completely independent of each other. This is just for our own reference, so that when we're going through Zen Orchestra and we're having a look at virtual machines, I'll be able to pick this one out. This is my Home Assistant VM. Don't necessarily have to put in a description, but I will. I literally was about to put in description in the description. Virtual CPUs, going by minimum recommendation, we want 2. I'm not going to bother with the topology for the CPUs here. Doesn't really matter. This is all to do with how many sockets you've got, how many cores are on each socket, and so on. Doesn't really matter, at least not for this sort of installation. And we want 2 gig of RAM. So that satisfies the minimum requirements. Like I say, you can pick something else if you want. For now, I'm just going to go with the defaults. Now, as far as XCP-ng is concerned, you have to tell it where the operating system is going to be coming from. So that's either through an ISO file, a DVD, but it doesn't really matter because we're actually going to be booting off an actual a virtual hard drive that's already got the operating system and software installed. So I could, for example, say, oh, we'll just go with an ISO and tell it to boot off the XCP-ng tools, for example, or I could tell it to boot off the PXE network method if you want. It doesn't really matter because, as I say, it's going to get changed anyway once we actually finish this. Interfaces. Well, this is a test lab, so it doesn't really matter. I don't really have much choice, really. I've only got 2 network interfaces. One that's more to do with the infrastructure and management, one's to do with storage. When you're dealing with a real network, and in my network, for instance, I'm running XCP-ng hypervisors, they've got virtual network interfaces that I can use for my virtual machines, and each one connects basically to a different VLAN. So the idea is, on those ones, there's multiple interfaces that I could pick from for my virtual machines, and it'd be a case of I would want these to be in a dedicated home network VLAN. I've actually covered network security, particularly around the home, for example, where you want to separate out all of your computers into different network areas, into different VLANs, and separate those out through a firewall. Because the idea is home network devices, smart home devices, IoT devices, whatever you want to call them, typically security isn't top priority for these vendors. So the trouble is, they are more vulnerable to being hacked, especially if they're going to be out touching a cloud, for example. There's always the risk that somebody has the potential to get into your network through a smart home device, and that could be used as a jumping point to the rest of your network. So, like I discussed in that particular video, the idea is I would have a dedicated VLAN for my smart home devices, and that's for the devices that need an IP address, ones that physically plug into the network or connect into Wi-Fi. One's on Z-Wave, Z-Wave, Zigbee, that doesn't matter, that they're all separate anyway. But when it comes to the ones that's connecting through IP, they're in their own dedicated VLAN and they're stuck behind a firewall that gives them access to pretty much next to nothing. I mean, they will need access to the internet to be able to get firmware updates, for example, but I don't want them to be able to have the potential to be used as a jumping point to, say, my computer, for example, when I'm using that computer to access my online banking system, for example. So security is very, very important when it comes to even a home network. So it's a case of, when you're building a machine like this, make sure it goes into a proper separate VLAN so that it's isolated from the actual main computers that you've got, so it can't be used against you. I mean, I do trust the devs who are working on this sort of stuff, but you just never know. When it comes to security, you always work on a least privilege. This Home Assistant, for example, it doesn't need access to my printers, it doesn't need access to my computer, and so on. So it's a case of I'm not going to give it access to it. So it would go into an isolated VLAN for that very reason. So, like I said, in our case, though, this is just a test lab, so it doesn't really matter. Now, disks, interestingly enough, it hasn't actually picked out a disk. It picked out a certain number of processors and a certain amount of memory, but it didn't pick an actual hard drive. That's probably because we've gone with this other install media. I do find it quite amusing in the sense that there's nothing to install an operating system onto. I mean, if you pick out Linux or you pick out Windows, for example, it'll create a hard drive with a certain size. In this particular, it hasn't created anything, which, to be honest, doesn't really matter, because on the grounds we would have deleted anyway. So, in summary, we've got 2 processors, 2 gig of RAM, there's no hard drive, and we've got 1 network card. Now, there are 2 other things I want to do. first, and that is we're going to show advanced settings and disable boot the VM after creation. In other words, when I click on the create button down there, I don't want this to be automatically starting because I need to attach the drive first. And another thing I need to do is to change the boot firmware. I don't want it to run on BIOS because it won't boot properly. I need to change it over to the UEFI firmware instead. So that's pretty much the changes that we need. Just double checking. Okay. So we'll tell this to create this virtual machine. Off it'll go, and it'll create it, but it's not going to do anything really. I mean, if it were to boot up, it would try and go and download a operating system if it could over the network, and it won't be able to. What we need to do is to actually attach this virtual image, if you will, that we've downloaded from Home Assistant, because that's the operating system and all the software that goes with it, and that's what this virtual machine is going to actually be using. Now, when it comes to actually attaching the drive to this virtual machine, what we can do with XCP-ng is we actually can import the actual disk. So if we go down to this option here, which is import, and you can see there are actually two options. One is to import a VM, one is to import a disk. If you go to VM, it actually gives you the option to install from an OVA file or an XVA file. So that's where basically you've got a hypervisor, you export it out to effectively a virtual appliance. All the information, everything is contained within that export file, and then you can import it all back in again. So it saves you having to create that virtual machine like we did. Now, what the devs have done for Home Assistant, it seems, is to be a bit more flexible. They've created multiple types of images, so it's not a complete virtual appliance they've given us. They've given us an actual, in this case, it's a VMDK file. So what we need to do is to go over to disk and tell it to import a disk. So I do actually have to tell it where we're going to be putting it to. So it says the 2 SR. So I need to go to here. Now I've got options because I've got two hypervisors, each with their own local storage. But I want to put this into shared storage. Makes sense because I want any of these two machines here, or at least two at the moment, to be able to run this virtual machine, which means they need access to shared storage. Because obviously if I put this into the shared storage of XCP1, well, XCP2 can't get access to it. And if XCP1 goes down, well, that's it. I can't spin this virtual machine up. But by putting it into the actual shared storage, in this case NFS, I can actually give both of these XCP-ng hypervisors access to it. So either one could run their virtual machine, and that sorts my redundancy problems. So we'll pick that one. Now it's asking to drag a VMDK or VHD file here to import. If I click on it, it actually gives you the option to browse through your folders, for example. So in my case, I'm going to go to downloads, and there's my VMDK file. So it's already highlighted that one as it happens. I'll just select that one, click on open, and then off it goes. So I want to, it's giving us a bit more information about it there, but I'm going to say import that file. Okay, so it's now imported the file. Not surprisingly, as you can see, the size is 32 gig, which lines up with what the actual the website was telling us. I mean, if I go back to the website and go back to the minimum specs, you can see they were referencing 32 gig back there. So we've now actually got a disk that's been imported basically. So what I've got to do now is to actually get the virtual machine to actually use that disk. Well, now that we've actually imported the actual VMDK file, or at least basically copied it across to the NFS share, the next thing to do is to actually attach that drive to the virtual machine that we created. So I'm just going to go over to Home, then over to VMs. Now, by default, it only shows you virtual machines that are running, so I'm going to clear the filter out so that we just see all of them. I'll then go to that specific virtual machine. We'll go over to disks. Now, at the moment, it doesn't have any disks, so I need to actually get it to use that disk we created. So, I mean, you've got options. You can create a new disk, but you can also attach a disk. So I'm going to click Attach Disk, and then we've got a drop-down list. So there's ones that you can pick from, you know, different local storages on different hypervisors, but what we're interested in is our shared storage over here, the NFS, specifically that VMDK file. So we'll select that, and then we've actually got to follow that up by telling it to attach the disk. So that's now attached. Now, one thing I'm going to do is go over to Advanced, Now, I'm going to disable the option to boot from the network because I don't really need that. I don't want it to go and start going over to booting off the network first, because it'll just take a bit of time. What I want it to do is boot from its hard drive, and then that should boot straight into the operating system. I mean, there's various other options that we can set. That's something I'll do probably later on. So for example, because this is a smart home hub, the idea is I'd probably want this running 24/7, in which case I would want it to be powered on all the time. I would want to protect it from accidental deletion, accidental shutdown. The only thing is, well, it doesn't really matter in the case of a test lab. So in my real actual live network, those are features I've enabled. But in this particular case, it's just a lab, so it's not something I do need running 24/7. Just double checking the firmware is set correctly. So if we now go over to the console, click on the start or play button, if you will, this should then boot up the actual virtual machine. It should then start to boot off that hard drive. It just takes a bit of a while before we actually see anything here. So there you go. So starting to see something, so it hasn't quite initialized the display yet. So there you go. So you can start to see the bit of information as it's booting up. So you can see the fact that it's going through all this information about partitions and so on. We know that it's already accessing the drive and it's already starting to boot actual Home Assistant off that hard drive. So this is going to take a bit of a while. So I'll just pause the video there and bring you back once it's all up and running. So there you go. The computer's now booted up. So we didn't actually have to install anything as such. It's not like other systems where you would build a computer, for example, or buy a computer, install an operating system, download and install some software. Everything is contained within that image that we've just downloaded. So all we've had to do is just to create the virtual machine and then effectively attach the virtual hard drive to it. So it's kind of like similar to if you had a physical computer and all you've done is just gone out and purchased a hard drive that somebody's done all the installation for. Then you just plug it into the computer. So it's kind of similar, except this is a whole lot easier, quite frankly, and a whole lot better. Now, the only catch for me is that you can see here it's giving us a URL. Now, this particular computer I'm on is not in the same subnet, so it's giving us the IP address that it obtained through DHCP. Typically, that's something we would probably want to change. You don't necessarily have to give it a static IP address. You could reserve an IP address through DHCP, for example. You can make sure that DHCP is updating DNS as well to tell it, and then that way you can reference it through an actual host name, for example, instead of through the IP address. The one thing to bear in mind, though, is the connection's through HTTP, not through HTTPS, so it's not a secure connection. Now, in my case, this is a test lab, so this computer that I'm working on is sitting behind a firewall. So it's in a different VLAN going through a firewall to get access to that IP address. I'm going to have to update the firewall to allow access to that specific port there. So I'm going to do that, and then once we're ready, I'll bring you back. Well, as you can see, I managed to update the firewall to get me access to Home Assistant. Just a reminder though, this is HTTP that we're connecting through. I mean, I didn't type in homeassistant.local because the computer I'm using to connect to it on is on a different subnet. And it's also got to go through a firewall. So I don't benefit from that name resolution opportunity, whereas I would if the computers were on the same subnet. So in any case, now that this is up and running, we need to go through this basic setup wizard. And it's asking for a user account that you can use to log in and manage Home Assistant with. So I do like that in the sense that it's not expecting you to, out of the box start using like the root account, for example. So it makes sense to go with a name that's unique to you, ideally. You don't want to be using something like admin or administrator, supervisor, root. You don't want to make it easier than it could be for a hacker. So for that reason, I'm going to just go and I'm just going to call this Bob for the sake of argument. So Bob's the user who's going to be logging into this. I would suggest using a strong password, something much more complicated than longer than I'm using. This is just because of it being a lab and the fact that I'm doing it on a video. If I made this a long password and more complicated, I'm bound to make a mistake, and I end up wasting too much time trying to fix it. Basically, even that short, I can still mistype things, and I don't want to be pasting things in with a like a password manager, which is something you should be really using for the sake of I could accidentally expose a legitimate password over the internet, which I don't want to do either. So for that reason, just because it's a video and it's in a test lab, I'm just going to keep it fairly simple. Now, once I've filled in those details, we then go over to the option to create account, and it'll create our account. Now, it wants to know where you are. Now, for whatever reason, it seems to go to Amsterdam. I don't know why, but you can change all this if you want. This makes a lot of sense if you're going to be doing this and you're going to be using something like geofencing, for example. It really helps if this box knows where it is compared to where you are, for example. So these sort of things are really useful to have. And you can give it a name. If you're going to run multiple home assistants, you might have, you might be managing ones in different locations. For example, maybe you're a landlord or something, and you've got a home assistant with smart home technology and all of the actual properties that you're renting out. That seems to be becoming quite popular apparently, but in my case it's just for my own home. But you'll be filling in all this sort of information that will be useful. For me, it's just a test. I'm not going to bother. Click on next. Now this is where we get into one of those topics of should you, shouldn't you. Entirely up to you. I like the fact that this is information that it's going to gather, and it hasn't actually by default selected it. In other words, you don't have to opt out. If you want to do this, you've got to opt in. And I really like people who go down this path. There's too many like companies out there. They enable this by default, and it's very easy to accidentally, be giving information away. And it's one of those things where, I suppose it's debatable, because the problem as I see it is I don't truly know what information is being given out. So the less I give out personally, the better, quite frankly. So click on next, leave those as are. Now, we've set up this account here. So it says, these are the devices are representing Home Assistant as your integrations. You can set them now, do it later. For the sake of argument, I'm just going to leave that as is, to be honest. I'm just going to click finish, because the video that we're doing here is just how do you actually install Home Assistant as a VM, really. I'm not going to go down that rabbit hole of how to set it up afterwards, all the wonderful things you can do. That's just way too many things to do. So I'm just going to click on that little button there. Do you want to stay logged in? Yeah. Ooh, Lovelace. I like that. Probably in the name of Ada Lovelace. So anyway, we're now logged in and we've got access to the basic Home Assistant. Now, one thing I can tell you is that when I set this up in my actual home network, it actually went out and it discovered various devices straight away. So we're talking about things like devices that are on the Wi-Fi, devices that are on the physical network, for example. In other words, devices that are working and operating through an IP address. So by that, we're talking about things like Lifex light bulbs that are on Wi-Fi, Philips Hue, for example, which is plugged in physically to a switch. These are devices that are all in this same subnet. Home Assistant could pick those sort of devices up and connect to them straight after. Now, in my particular case, I'm running all sorts of things. I've got some on Z-Wave or Z-Wave if you prefer. I've got some of them on Zigbee as well. Now, that means that out of the box, a device like this, which is a virtual machine, it certainly doesn't have a Zigbee radio, and it certainly doesn't have a Z-Wave radio, so it couldn't get access to those sort of smart home devices. So these are things you're going to have to add in. Debatable as to which way you want to go in terms of, your preference for controlling devices, but personally, for me, it's either going to be Z-Wave or it's going to be Zigbee. It really depends. I'd love to be able to pick one specific one, but what I'm finding is that different vendors do different things. Z-Wave, you've got to pay for a license, so it tends to cost more, but I'm finding there's certain smart home devices I do like, and they're only available in Z-Wave. I've got some devices, on the other hand, that I really like what those vendors have done, because they actually give you the option to pick whatever radio you like. So you can have it supplied so that it's capable of running on a Wi-Fi, it's capable of running on Zigbee, and so on. And if you change your mind somewhere down the line, you've just got to go and purchase that radio separately, and you can just change it over. So it's very, very flexible. And we're still in this phase, I think, where the industry hasn't sort of like settled on a standard yet. I mean, even Zigbee, which is an open standard, some of the vendors are actually putting their own proprietary pieces into it. So it's still up in the air. But the good thing about Home Assistant is that I'll be able to get access to all three of those types as long as I have the actual controllers for it as well. So that's pretty much for it for this video. I mean, this is just a test VM. What I would have to do on my real network, for example, is plug in. So for example, I've got a Zigbee USB controller. I'd have to plug that into the actual physical computer, and then I'd have to make that available through the hypervisor to the VM so that it'll be able to get access to the Zigbee network. I'll have to do the same with Z-Wave as well, because at the moment I'm running things on a different smart hub solution. I'll have to migrate across, but at least this gets you up and running. Gets you your account up and running. You can log in, and as I say, it'll pick up devices that are on IP anyway. So at least it gets the ball rolling, if you will. But it's relatively straightforward. Now I really like this because the fact that I can go back to Zen Orchestra here, for example. I mean, I can just take a snapshot of that specific virtual machine. So if a patch comes out, I can tell the actual system, take a snapshot of this particular virtual machine. We do there's migrate option, there's copy option. Yeah, I can take a snapshot of that virtual machine, and if things go pear-shaped after I've upgraded it, I mean, I'll update it actually through the actual management portal of Home Assistant. But if things go pear-shaped, I can just roll this back to the previous snapshot. Likewise, I mean, just out of curiosity, I wonder which. If we go over to, oh, well, there you go. So Zen Orchestra is actually running on XCP-1, and it's actually put Home Assistant onto XCP-2. So these two devices, these two virtual machines, are already running on different hosts. So if XCP-2 were to fall over, I can always spin it up on XCP-1, but I've got to do it manually. I haven't set up any sort of high availability on this sort of thing, but it's something to consider. But it means I've got such great flexibility because it's a virtual machine, and it was pretty straightforward to set up. I think the hardest part was actually finding where the actual installation software was on the website. That was the hardest part, quite frankly. Anyway, do hope you've enjoyed watching this. But that's all. Thanks very much for watching. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.